In this movie, we're going to go over the area volumes method. So this is a method where you may have two surfaces which you wish to compare, and you're going to use a 2D polyline to limit the volume result. Think of this 2D polyline as acting kind of like a cookie cutter that cuts between the top and the bottom surfaces. Let me show you what we're doing here. So I've got two grids that are representing two surfaces, and I've actually got both the surfaces in memory right now. And so I'll use a tin just so that you can see what the two surfaces look like. Here's the top surface. And here's the bottom surface. And when I look at this from the top, we're going to generate a volume that fits inside of this polyline. I can further make that easier to visualize if I add a value of thickness to this 2D polyline. And I'll change my visual style so that it's easier to see. There we go. So now we can actually see the cookie cutter cutting through the bottom surface and the top surface, and you can imagine the volume result that we're going to get is what's inside of that cookie cutter. There we go. Okay, so now we're ready to do a volume calculation. Now the first step that's required when doing an area volume calculation is that the 2D polyline needs to be draped to each of the two surfaces and extracted as a break line. So here I'll go through that process. In the Design Tools section, we can find the Drape function. I'll pick on Drape. Now what Drape will do is it'll take any entity that you select and it will project it onto the surface that you name. And so here it's prompting me for which surface I want to project to, and I'll hit enter to select bottom. It asks me to pick the entity that I want to drape. I'll select that. I'll hit enter. Do I want to delete the original? No, I don't, because I'm going to use it twice. Now I've done the first step. I've draped to my bottom surface. Now what I need to do is add it to my surface as a break line. I'll go to Extract Breaks, tell that I'm going to add a break to the bottom surface. And here I select that draped. Now it's a 3D polyline, and I'll hit enter. There we go. And now I'm finished with that polyline, so I can delete it, just to cut down on clutter. And then let's repeat that process for the top surface. So drape, select the top, pick my 2D polyline, enter. No, I don't. Now I can see a new line up here. Extract breaks to the top surface. Enter. And again, I can delete it because now it's been added to memory. Now we'll go back to top view, and let me draw another tin just so you can see how we've changed the surface. Here I'm going to draw just the top one. And so now we can see that all of the triangles that are drawn have their boundaries right on the polyline. So now we know we're ready to start doing a volume calculation. So let me just turn it on the side so that you can see what we're doing. I'm going to select Area Volumes method. So here I'll pick my newer surface to start with, and my older surface. I'll ask for cut and fill volumes. I'll select OK. Now it asks me to select entities. This is where I select a 2D polyline. I'll hit enter. There's my first volume report. Notice also, we'll go back to plan view, that the area has been labeled as area 1. If there were multiple 3D polylines in this example, we would find label for each of the closed polylines. Now let's use a different method. Select the newer, select the older, and this time volumes and average values. I'll select OK, select my entity, hit enter, and there's another volume result. So I'll open that up. So it tells me that my net volume using the volumes and average values method is roughly 6 million. And as I scroll back here and I check on the net volume here, I will also see we're at roughly 6 million. In the following movie, we're going to go into some more detailed methods of verifying those results.